Hi, good morning, good afternoon, wherever you might be. My name is Andy Walton. I'm the Senior Vice President, not Senior Vice President, let's just call me Vice President of Technical Sales. And I'm joined today, as usual, by my Senior Cloud Advisor, Faisal Mohammed. How are you doing today, Faisal?
I'm doing great, Andy. Thanks for inviting me to this call today. Hello, everyone.
Yeah, it's good to have you. Faisal and I, typically once a month, we get together like this. And as you can see, I do this from my living room with my Densify wallpaper in the background. And Faisal, you're at home or maybe in the office, but we've got a great webinar, great content for you today. Faisal's going to lead our discussion on 10 fundamental strategies to controlling your cloud costs. If we move to the next slide there, Faisal, I think there's our names there.
You should see the slide before we begin right now, Andy.
Yeah, it's actually not moving. So let's try that. Make sure you're not on pause and move that forward.
Oh, maybe that's probably it. 1 second. I will just do that right now. And
there
you go.
Perfect.
Are we good now?
Thank you.
Excellent.
Yeah.
Thank you.
So yeah, just a little housekeeping for everyone. There's a question and answer, or at least a question pane over your GoToWebinar. If you have questions, please post them in there, and we will have time at the end of the session to address those things. And for anyone asking, we will post a recording of this presentation early next week.
Absolutely. And also just a heads up, I mean, if both me and Andy, we're both active on our LinkedIn. So if you guys want to follow us on LinkedIn or our Densify webinars, you can always follow us there. You can see what we're up to and join us on these webinars too as well.
And yeah, the agenda for today. So obviously our focus is we're going to start with just examining your AWS cost and usage reports. We're going to talk about where to find those hidden costs and how those things actually affect your bottom line in many cases without you even knowing. So Faisal's going to take that content, and then we're going to dive right into those top 10 strategies on controlling your cloud costs. And we'll wrap the presentation today with a little discussion on the new cloud operating model and this whole new concept around cost governance called FinOps, and what that is and how you can start to build a culture of awareness of that across your organization. And stay tuned at the end of this presentation. One of these lucky participants today, the people actually attend, not the folks that weren't able to join us and get a recording later on, but we'll be providing a $100 Visa gift card. That's a physical card. For one of the attendees. We'll do a random draw and we'll announce that winner at the end of our session. And so let's dive right into it. Over to you, Faisal.
Thank you so much, Andy. Hello, everyone. So thank you so much for taking the time out of your busy schedule today to join and learn about these 10 fundamental strategies on how you can manage your cloud costs. So let's get started right away. One of the first things that we do when we work with customers is that we say, okay, well, do you have access to your AWS cost and usage report? What AWS does, they do a great job. They give you a detailed billing report called the cost and usage report. And as you can see in the screenshot, it's a breakdown of the actual cost. What exactly is your monthly cost made out of? And there are various columns, and you can see there are columns with product code, usage type, billing period, what's your amortized cost. Now, the challenge is here that while this data is coming and it's very, very detailed, it's very, very granular, it can become too overwhelming. And there's not enough, insights that you can derive from using some of the free tools that are out there. So what we did here at Densify is that when we're working with customers, we built what's known as a cloud cost intelligence solution. And the objective here is that, okay, well, take that CSV file that has so much line items, sometimes it's over thousands, maybe millions even, right? And make it simpler to read that cloud bill. And what we are doing here is that, as you can see in this graph, we're trying to understand what exactly is making up the essential cost of your AWS bill. We're actually going into the cost of your service. We're looking at it and we're trying to make observations as to, okay, well, what exactly is your cost made out of, and give you expert advice. We try to look for trends. We try to say, by the way, okay, you are buying these services. These are by services by account. And then we go from an account level to go say, let's see what are the top services that make out these accounts, or what are the API calls, and try to find these insights, these trend lines. And with that being said, we can start looking at what are some of these strategies that we identified when we work with customers. So as you're working in the cloud, one of the very, very most common service that we see our customers use is EC2, Elastic Compute Cloud. And AWS or GCP or Azure, they offer these virtualization techniques. And so you have these virtual machines that are available out there. But the dilemma with that is that as engineers, you need to select an EC2 instance type, for example. And there's various instance families and types that are dedicated to different types of workloads. So when you're a developer, you got to start thinking about your workload. You have to start thinking, is my workload peaky? How often does it spike? Does it spike at the end of the month? Is it a static workload? Is it compute intensive? So what you see are these various instance families. You have compute intensive family, you have a memory intensive family, you have general purpose workloads for dev test, you have high performance computing and storage optimized. So as engineers, you need to decide that. And generally speaking, you know, speaking from my background, I was a technical consultant prior to this. You know, we tend to think all our workloads are compute intensive, but that's not necessarily always the case. You need to understand that. Additionally, what there's out there is that they have various chipsets. In the case of AWS, you have Intel, AMD, and Graviton. So you need to decide, okay, well, what's exactly are the differences? And education is the key here. So in this case, what we did is we went to the AWS billing calculator, and we said, okay, let's take an example. What's the difference? Why is this important? And here's an example of on-demand monthly prices for a select instance types that are available in the US East with the Linux AMI. And as you can see, we have a T3 large that costs around $60 per month. Well, if I chose an M5 large, which has 2 vCPUs, all of these, by the way, have 2 vCPUs, but various memory and network characteristics. You can see if I chose an M5 large, it would cost me $70 per month. And conversely, if I chose a C5 large, it would cost me $62 per month. An R5 large would be $91 per month. And all the way to a Z1D large, which would cost me $135 per month. So for 2 vCPUs, there's a whole spectrum of different choices out there. And you know, both Andy and me, we can talk about this. What we see with customers is that they don't know this. Engineers just pick like the biggest one and say, I think I need that. Well, that's where that education part comes into play. And the other thing that we also talk to customers and engineers, we tell them, by the way, just so you know, not only it's important to understand your workload, but also understand, you know, what's the profile, what's the frequency of that workload. If you are doing some kind of dev test workload and you're running it for only a couple hours a day, well, then perhaps you should go with an on-demand, because you know, an on-demand gives you an hourly billing rate, and then when you're not using that compute resource anymore, you just turn it off. But what if you have a steady state workload, a production workload, and this thing needs to run 24/7, 365 days a year? Well, in that case, what's out there with AWS is that they give you discounts. And these discount vehicles are called reserved instances or savings plan. And so what you do is you commit to AWS to say, okay, well, I'm going to spend this much money, or I'm going to commit to using this many EC2 instances. And in exchange for that commitment for a 1 or 3 year term, you get a better rate, a discounted rate. Again, education is the key here. And what we do here at Densify is we help our customers understand and continuously optimize their compute. So for example, engineers and developers, as I mentioned, they're not aware. They just go ahead and pick the biggest instance, because as a developer, what do you care about? You care about your system running all the time, and you worry about not having any code audits done. So you go ahead and pick the strongest, the biggest EC2 instance out there. And the hidden item that you're getting charged here for is an oversized EC2 instance. So what we do here at Densify is what we're doing, we're trying to understand that workload. And by understanding the workload, what I mean is we look at the CPU, we look at the memory, the disk, and the network performance. And we look at our not just 14 days, but over 60 days, up to a year's worth of data to understand those end of quarter patterns, those monthly patterns. And then what we do is we take that and we try to match that with the most optimal EC2 instance. See, there's over 270 different EC2 instance types out there. So we got to figure out what's the best out there that gives you not only performance, but also cost savings. And the second bullet that I want to talk about here, what's very, very important is that we will never compromise performance in exchange for cost savings. Andy, any thoughts on that?
No, I think it's just important to note that it's so difficult to choose that instance, and like you say, the largest is the best, but quite often it's just among the hundreds of different choices. It's only by analytics, analyzing that history to really understand where that optimal instance is. And it's very difficult to get that type of answer from a free tool, which will make some very simple savings recommendations.
Absolutely, and that's what this dashboard is showing for an engineer. You know, when you chose something, for example, this engineer went ahead and selected a C42 extra large Linux because they thought it's a compute intensive workload. And what we did is we analyzed it and we said go to an R5A large instead. And what we're doing here is we're actually educating the customer, the engineers, to say, by the way, you chose a C42 extra large, but when we look at the compute utilization profile here at the bottom, we've looked over 60 days of data, and then we built a representative day to say, what does this look like on a typical day? And you can see this thing barely uses 15% CPU utilization. So it's not necessarily a compute intensive workload. And so then we say, maybe you should go to an R5A large because that's what we identified as the best performance and cost optimization solution for you. And then we actually educate again by showing you what that workload would look like. So now you see, this is what your current workload looks like on the C42 extra large. And here's what it would look like on the R5A large. So education is the key here, informing your engineers. So other things that we do as well, and I go through them, is that when we work with customers and we're looking again at these cost and usage reports, we're seeing these trends. People are buying, EC2 instances. And one of the things when you select an EC2 instance, when you're configuring them, if you've gone through the exercise, is actually selecting an AMI. You also have to select your subnet, you have to select your security group settings, whether to attach EBS volumes, etc. But one of the key things that we try to educate customers is that, hey, there are free and open source AMIs out there. And where applicable, think about using them, okay? For example, here's a C5 extra large instance, again, running on demand in US East. And you can see the price range when we just plug this into the AWS cost calculator. A Linux AMI for that C5 extra large would cost $124 per month. In comparison, if you use the Windows, that would be $258 per month. And then if you use a SUSE, that would be $197 per month. So becoming aware, does your workload, if your workload is actually based on a specific, say, AMI and you're stuck with it, then yes, you have to go forward with it. But if it was not, then being informed and choosing the right AMI can actually make significant cost savings when you add them up. Other things, AMD has done a great job in coming to the market with this EPYC chipset here, and they started at AWS and now they have it in Azure and GCP. So another recommendation that we say to customers that, hey, if you have not considered AMD instance types, start taking a closer look at them, because not only you get the same or better performance than Intel chipsets, but they also give you cost savings as well. And these cost savings can also vary by geographic region. So as an example, we're looking at an R5 extra large instance. It's running Linux on demand, And this R5 extra large, as I go through the very first row here, you can see that in the US East, it's costing $367 per month. In the US West, it's costing me $408 per month. So again, choosing which geographic region. If it's a production workload, yes, you want it to be as close to your customer base. However, if it's maybe a dev test workload, does the latency matter that much? Think about that. And as you can see, Andy, go ahead.
Sorry, I was going to jump in and just say it's also important to note that the analytics sometimes will actually tell you and make a recommendation to say you should have an R5 versus an R5A, and even knowing that it might not even be available in certain regions, like in the EU and in Stockholm or in the Middle East there.
Absolutely. That's a very good point that you make there. So being aware of that is very important. And just going with the R5A2 extra large as a comparison, you can see the price difference between US East R5 extra large. You can see it's almost $50. And in comparison, if you go to Mumbai, that's $110. So again, be aware of these pricing differences. And again, the R5A or the AMD chipsets give you the same or equal or better performance, and they vary as well. So it's a good option for you to look at. So moving forward, other things, as I mentioned, AWS has these savings vehicles, RIs and savings plans. And it's very important for you, again, if you have a workload that's steady state, start looking at these RIs and SPs and understand, okay, well, if I purchased RIs today, how well are they being utilized? And not only how well are they being utilized, but also how much of my compute is covered by these RIs. And RIs come in two different flavors. They come in, they have the two different classes, standard and convertible RIs. With convertible RIs, you have the ability to switch instance families, but there's a catch. The catch is that you must spend equal or higher amounts. So there's these true up costs. So you become aware of them. At Densify, this is a screenshot of what we're doing here. We're looking at these RIs. There's about 45 RIs here. And what we're trying to do is say, okay, well, these RIs are actually underutilized based on what you're actually using today. And you should convert them to these 16 RIs. We have more details coming up. And what we want to do is we want to minimize that true up cost. So we actually go through a painful calculation process to come up with these recommendations for you. And what we do is we help you manage out of these convertible RIs where it makes sense so that you're actually increasing your RI coverage and utilization. We take these RIs, we break them into these exchange sets, and we give you very, very granular details on how to exchange them so that you minimize that true up cost. Now, another thing that you should be aware of is that while there's savings plans and RIs out there, be careful about oversubscribing to them. So what I mean by that is if I have an EC2 instance and I have an RI that I've already purchased for it, then don't go ahead and buy a savings plan and subscribe to that as well. Don't overcommit to that. Andy can talk to it. I mean, we were in a customer trial where we found these customers that they had actually invested heavily in these incorrect RIs and they were stuck with it and they wanted to buy savings plans on the other hand, but they had already bought them. So there's no point oversubscribing to them, paying twice. Right, Andy?
Yeah, there's one great situation where a customer is got a long-term commitment to a big savings plan. The good thing is for them is even though they're we can show them the way to actually optimize the instances underneath that, and it's basically creating headroom. So as their environment is growing very quickly, instead of buying more savings plans or at least committing to a higher hourly level, they can actually use the so-called white space in that account, which is around 40%. So a significant amount for that particular customer. And we're going to help them realize some significant savings where they'd have to typically go out and just purchase more and more.
Absolutely. Thanks, Andy. So other things we just want to mention there, we did a great webinar on this just last month. Here's the link on it. So if you ever want to go ahead and understand a little bit more about the nuances between RIs and savings plan, it's a great webinar. Please go check out. That's the link there below there. Other things that you want to be aware of is, getting rid of resources that you've provisioned. The thing is that, when you have EC2 instances and you provision them, you have this concept of elastic IP addresses, and basically it's a static IP address that you can associate with a network interface, and it comes with an AWS account. By default, AWS gives you about 5 elastic IP addresses per account, and then you can always increase that quota. But the thing is that the IP address is a limited resource. So why do you need elastic IP addresses? That basically, if you were to shut down your EC2 instance and restart it again, it may spin up on a different EC2 host. And as a result of that, you may lose that IP address, so you'll get a different IP address. Elastic IP address gives you a way to keep that static IP address there. But again, it's a limited resource. In this case, AWS wants to make sure that you're not actually, going ahead and getting all these elastic IP addresses and holding on to them. So there's a small hourly charge out there if you have an elastic IP address that's not associated with a running instance. Again, looking at the cost and usage report, what we do as experts, we try to identify these things. And here's an example where we've said, okay, well, someone's actually spending almost close to $1,200 per month on these elastic IP addresses that are actually idle. And we inform customers, by the way, we should educate the engineers about, okay, well, if you're not using them, start releasing these elastic IP addresses because you can lower your cloud cost. Other things that we do, well, the curve file that we set is really, really good. It has a lot of details. The problem is that the details are embedded in there, and you got to start looking at some of these trends. As an example, start thinking about your CloudWatch. CloudWatch is a great source tool that basically AWS offers here, where you can actually send all your services, can send your metrics to CloudWatch. And then with these metrics, you can identify trends and you can see what your utilization profiles are. What you can also do is with CloudWatch is you can actually send logs. And these logs can be grouped together into what's known as log events. And these log events are basically, as long as they come from the same source, they're a single log event. And you can group these log events into what's known as log groups. Upon these log groups, you can do things like retention periods. So I want to keep my logs for 30 days or 90 days. You got to keep track of these CloudWatch logs, because again, here's an example of a customer where what they were doing is that an engineer inadvertently decided to send a lot more logs than usual because they forgot to enable that filter on their CloudWatch logs. And what we did is here, we actually looked at the trend of utilization over the last 10 days, and we can actually adjust this by parameter. And we noticed that, hey, over the last 10 days on this one particular day, their cloud log ingestion costs went up by 86% above average. And what gives? So we started digging into the details. And here's what you see. What we have here is an outlier report. So this yellow line is the actual moving average over the last 10 days. And this blue line is 2 standard deviations from that yellow line. And the black line is the actual cost as it's moving across those last 10 days. And what you can see here, these red dots here on those black lines are those outliers. So on this particular day, they were actually 86% above the moving average. And then we pull into the details to say what gives. And here's actually the details. What you can see here is that they actually delivered some extra logs additionally because an engineer forgot to disable one of the filters. And so we quickly addressed that issue. We let them know right away, by the way, did you know your cost went up? And keep an eye on these outliers. This is very, very important. Something that unique that we do here at Densify. And then the customer was very, very appreciative of what we had identified here overall. Any comments on this, Andy?
I think it can be used in the reverse as well, Faisal, which is really neat because we show an outlier on the reverse side, which would indicate a lower cost than normal. One of our customers found a configuration item around RDS where someone had actually changed the way they configured, the way they launched that service. They dug into it and found out, wow, that's a configuration setting we should be using all the time. So the reverse is true as well. By doing that, they were able to save essentially hundreds or thousands of dollars a month by changing a configuration. It was pointed out by this whole outlier analysis.
Excellent. No, thanks, Andy. I remember that example. That's a very, very good one there. Thanks for reminding me on that one. So moving forward, what else can we do here? Well, S3 storage. S3 is one of the very, very common storage that we come across with a lot of our customers. And it's actually one of the very, very first AWS services that I recall came out of. What happens with S3 is that, customers are not aware that there are various storage tiers out there. And these are the storage tiers that you can see. There's S3 standard, S3 intelligent tiering, S3 infrequent access, one zone infrequent access, Glacier, and Glacier Archive. And each of these storage tiers have different characteristics. For example, in the intelligent tiering to the one zone, you have to keep data for at least 30 days. In Glacier and Glacier Archive is, I think, 90 and 140 days approximately. So there are different characteristics with them and about these storage tiers. So education is important to actually inform developers that, hey, you have various options out there. What I see with customers when I look at their curve files is that everyone picks S3 standard because they just think that, hey, that's the de facto. But the challenge here is that there's also hidden cost associated with that. And as you can see on the spectrum here, there's a frequency access. So what AWS advises you is that if you have hot data that's being accessed frequently, put them towards the S3 standard. And if data is becoming infrequent, you just need them for archival purposes, then start going towards Glacier and Glacier Archive. And if there are data that can be derived from, like if you have, say, for example, thumbnails can be derived from pictures, then consider using like one zone infrequent access. So the trick here is that to understand your data access pattern, how frequently is that object being accessed, and then manage them by shifting them between different buckets. Okay, because as you can see, your cost will vary by class. And then there are also other costs like data access or API costs, and then data transfer costs. So one thing that AWS has done a great job at is that they came up with what's known as a lifecycle manager. And here's a screenshot of that. So education is key here. Inform the developers that, hey, listen, if you have uploaded an object to S3 standard because that one day it was important to you, but as time has elapsed, consider building these lifecycle rules. So they're actually shifting these objects to the different buckets, different storage tiers here, so that it's going to cost you less and less every month. Okay. And I'll give you an example. We'll walk through this. So I've actually looked at the pricing calculator and built this table out here. And let's take a look at this example. Assume you have 500 terabytes of storage here in S3 in Northern Virginia, and assume they're frequently accessed. Well, I'm looking at the actual cost per gigabyte. I pulled them out across the various tiers here, as you can see. And you can see that storage cost it's $11,050 for S3 standard. If I want to S3 infrequent access, it's around $6,250. One zone IA is $5,000, and Glacier's all the way $495. So think about that. What if that data, I talked about access patterns, about 250 terabytes of them were infrequently accessed. So, instead of you throwing all the 500 terabytes into actually the S3 standard here, what if I build what if I use S3 intelligent tiering, which will automatically start moving those idle objects that are infrequently accessed to the S3 standard infrequently accessed bucket? Well, in that case, my cost can go down to $8,675. So that's important to know. Again, education is key to your developers. Let them know about these options out there. There's other things that you should think about. Data API cost. So as an example, let's assume on that 500 terabytes of data that I have, I make 50 million put requests and 100 million get requests. Well, here's that API cost, as you can see, that's going across making that request there. So now you start thinking about this. Okay, well, these API costs that I'm making there, can some of this data be cached? Can I use CloudFront to store them so I don't make that many fetching requests for the same data? An interesting thing I want to point out, that's why I put the Sao Paulo there, is that also it varies by region. So you can see that if my API cost was for Northern Virginia 290, if I were hosting that bucket in Sao Paulo, my API cost for the same 50 million put and 100 million get requests would be 406. So not only choosing that bucket, choosing where to host that, not only choosing the correct storage tier, but also where to host it is important as well. And lastly, think about data transfer cost. Assume, okay, of that 500 terabytes of data, you're making 200 terabytes of data transfer via the internet. So it's all traffic coming through the internet. In this case here, your data transfer cost is around $92,000 per month, right? And again, as engineers and developers start thinking about that data, is that data changing frequently or not? If the data is static data, can I use CloudFront and caching so I don't go ahead and keep fetching that data from the storage buckets? Think about that. And conversely, what if that data was not being sent over the internet, but it's sending to a region? In this case, again, think about Sao Paulo. Well, that's what that associated cost will be. So you can see that there's a lot of factors to think about, not just blindly choosing a storage tier, but understanding what that cost is. It's very, very important for engineers. So we look at EBS volumes. This is also something that we see very, very common, and it comes in with the elastic IPD addresses kind of hand in hand. See, with EC2 instances, you have storage options available. You have options with EBS volume or instant storage, and EBS volumes are much more preferable because they give you that persistence. But the problem is that when you are actually working with EBS volumes, is that when you're working with EBS volumes, when you terminate an EC2 instance, developers forgot to actually delete that EBS volume. And so the problem is that you have these orphaned EBS volumes that are actually stacking up cost, as you can see over here. Or conversely, you could also have EBS snapshots, and you're not doing any housekeeping to clean up these EBS snapshots. So what we do is we look at an inventory side. And an inventory side, what we're looking at here is we're saying that, hey, by the way, there are these EBS volume snapshots. Did you know they're about 180 days old? Is someone actually cleaning them up or not? Because that's what's attributing to that cost over there. Moving on. So also with RedShift clusters, this is actually AWS's data warehouse solution for petabyte size data. And it's a great, great solution out there for big data analysis out there. They have these dedicated node types that you can have, specialized node types that you can use for these big data processing. And AWS charges you for these compute nodes. And if you're not using RIs for them, then they charge you for them on demand. So one thing you have to be aware of is that if I'm not using these RedShift cluster nodes during my offline hours, let's start pausing them. This is a functionality that AWS introduced called pause and resume. And as you can see from this billing data we analyzed, on these days that are highlighted in red, these are the actual weekends. So why is your RedShift cluster running on the weekends if it's not doing any work? Are you aware of this functionality? Use these kind of scheduling functionality, the pause and resume, to actually shut down or pause your RedShift cluster nodes during offline hours so you don't rack up these costs that are out there. And going forward with this, the last tip that we have for our customers is to start thinking about infrastructure selection and tagging. Make right sizing as part of your infrastructure as code provisioning tools, whether you use CloudFormation or Terraform. Make right sizing part of your CI/CD framework. See, at Densify, what we have done is we've built a API, and that allows us to actually get the recommendations. So now you can actually punch them directly into your CI/CD framework. Engineers forget, oh my God, I have to actually shut that instance off or I have to right size that. But if you actually plug into a right sizing framework like Densify, for example, then you don't have to worry about them. They can simply deploy their code as part of CI/CD, and then their CI/CD framework makes that invocation to Densify and says, hey, can you tell me, am I supposed to be using the C5 2 extra large? And Densify says, no, that's supposed to be an R5 A large. Okay, great, excellent. I'll provision that as part of my infrastructure. It becomes automated. And additionally, look at tagging. We talked about the cost and usage report, but the best cost and usage report that is out there, you need to have tags. You need to know who spent what, whether it's that EC2 instance, whether you want to see the cost center, the owner, the resource tags. So automate that tagging enforcement. There's various governance tools out there at AWS. Here's an example. We're working with a customer. We looked at their tags and we identified, hey, here's how well you're actually utilizing their tags, and we're educating you about them. Moving forward, and I'm also being aware of the time. I'm sorry, I'm a little bit close to the edge here, but here's the reality of the FinOps and the cloud economics that's going on. In the old age of the cloud, old age of the data centers, all the infrastructure procurement was siloed. You had finance teams, you had your operations team, and you had engineering teams, and these teams generally did not interact with each other. What I mean by that is that finance said, okay, tell me what hardware we need to buy, what servers we need to procure, and we bought the hardwares for 3 to 5 years term, okay, and we bought them based on the the biggest consumption model that we could think of. What's the worst traffic that we could possibly have? And we have these VM sprawl, oversized VMs and whatnot. But with the cloud that came out there, that model started changing, and the dynamics started changing that we are noticing there. See, in the cloud, all the resources are out there for you, and they're available to you as a different consumption model. You actually go ahead and you consume them. And so you start thinking about concepts like high availability, fault tolerance, elasticity, and you realize that the cloud is a variable cost. It's no longer a fixed cost like the age of the data center, but it's a variable nature. And so what's requiring here, as we are seeing in this pyramid that I show you here, is that we're educating customers that there's a cost pyramid out there in the cloud. And while finance teams are saying, yeah, let's go buy a bunch of savings plans and reserve capacity, and they do give you discounts, start thinking about your actual instances too as well. Don't buy savings plans and reserved instances for oversized EC2 instances, because you'll just pay that much more. So the base, the foundation of this is just as much important. Make sure you optimize first and then buy those discounting vehicles out there. And so with that what we're seeing is this revolution, this dynamics of FinOps, or some people call it cloud financial management or cost governance. And what we're doing here is that we're trying to educating customers on building this set of standards and best practices and raising cost awareness across their organization. See, we're telling them about this concept of this cloud center of excellence. That's a great concept out there in the industry, where you bring a cross-functional team of experts. You bring in your finance team, your IT team, your engineers, your operations team, and they all sit together at the table and say, how can we execute upon our cloud strategy to get to the end goal overall here? So with that being said, what we're saying is that he can help go ahead and establish a culture of cost savings and make cost savings part of everyone's job. Raise that awareness. Have sprints, dedicated sprints as part of your developer sprints to say, hey guys, I know we have these sprints per month on features and functional release. Why not we have some on savings as well? Let's see how many EC2 instances that we can find that are idle, how many EBS volumes that are orphaned, how many RedShift clusters that were running on the weekend that should not be running, and educate your developers and your engineers by creating these dashboards. You get all the data from the curve file, but now give it out to them so they can now make informed decisions. Make right sizing as part of your enforcement day-to-day job, and make tagging part of your role. That's how you can go ahead and make that cost optimization journey more and more efficient in your organization. And lastly, also make that data available for all your executives out there. So with that being said, I thank you for this and listening to me. Andy, I'll pass it back to you, and you can go ahead and you can just take over from here.
Yeah, perfect. Thank you, Faisal. And while you've been going through the content, I've actually been answering a whole bunch of questions online, so I won't take any more just because we're past the time. I will say a couple things just in terms of contacting us afterwards. If you'd like to see and get some visibility into some of the trends in your own public cloud usage and where your optimization opportunities may lie and some of these hidden costs, feel free to start up your own Densify trial. It's a 14-day free trial. We offer straight through our website. Just go to densify.com, start up your free trial. You fill in some information. We'll get in contact with you and make sure we understand what your requirements are. We fire up a custom instance with your data specifically. It's all agentless in terms of how we go out and get that data from AWS, Azure, Google Cloud, or your containers, Kubernetes, or VMware on-prem environments. And then once we've got your data, essentially it's about a 15-minute process. Within that, typically that same day or early the next day, we will have some results to be able to share with you. So please feel free to come back and actually try it out with us. You got nothing to lose and lots of money potentially to gain. Let's see if we already have, and if you are already, I do see one question here. If you already are a Densify customer, how do you explore in more detail? Just get in touch with your account manager or simply send us an email through answers@densify.com. We would be happy to follow up. Two things left, the webinar that's coming up, as well as the winner of our $100 Visa gift card. So there's an upcoming webinar that'll be delivered by our SVP of Business Development and Marketing, Chuck Tatham. That's on the keys to FinOps success, precision, collaboration, and integration. A bigger in-depth discussion on the last two slides that Faisal was covering off with us today. Simply go to our website, click on events, and register away for that. And keep an eye on that page. There's going to be monthly webinars coming up in the months of October, November through the end of the year. And we don't have a slide for this, but I just wanted to announce the winner of the $100 Visa gift card is Heiner T. Could be Hainer T. I apologize if I butchered your name. We will be reaching out to you to figure out how do we deliver that prize to you. So congratulations. And for everyone else that is joined us today, thank you very much for your time. Please reach out to us at answers@densify.com. I just see a couple more questions coming up. How to get a hold of you. Go to our website, click the contact us button, answers@densify.com, and we'd be happy to follow up. Faisal, thank you very much for the very informative session today.
No, thank you so much, Andy. And I want to thank our audience for watching in. Again, yes, please do reach out to us. We're happy to help you guys. We're on LinkedIn. And again, Andy mentioned answers@densify.com. Thank you so much, guys.
Great. Thank you to all. Have a great day. We'll see you at the next one.